And I said that most of the only computer might have used GitHub. So, yeah, okay.
Awesome. So hello, my name is Madeline. I'm doing a PhD in physics. So we're going to talk about Git. And it's totally okay if you've never used it before or you don't know what it's going to be, because I'm going to start with some kind of like background of what it's for and why you might want to use it, because that's kind of, I think, the big barrier to learning it. Before I start with the intro, though, so if you have your computers with you, to follow along, you'll need a terminal with Git installed. So if you're on Windows, open Git bash if you've installed it. And if you can type git -- version, and it says something like git version, some numbers, it doesn't have to be the same version, just as long as it doesn't give you an error, that means you're ready to go. So if you don't have that working, so in general, so y'all have two sticky notes, a kind of pinky orange one and a yellow one. So if there's ever any like issue or something's not working, just stick up the pink one on your laptop, like on the back, and somebody, one of those people on the edge will come and help you. So if you have Git installed and you ran git -- version and it worked, put up your yellow sticky. And then I'll start talking. Okay, awesome. This is great. Okay, so how many of you have ever saved multiple versions of a file like this, like _v1? I'm gonna just I've done this. How many of you like to save intermediate steps of things? Like if you're working on your intro and you're like, ooh, that's a good sentence, but I don't know if I'm going to use it. You put it in a different document or something like that, or you save like lots of versions. Yeah, I do this. How many of you have ever, while you're writing or you're coding, you delete some stuff and you change it and then you regret it and you wish you could go back to the thing you had written before? How about you go back to something you wrote like 6 months ago and you're like, why did I do this? I have no idea what this variable means. How about if you want to like experiment with something, like you're going to use the old version of it and then make it new, you like make a new file for that and you keep like making branches of things as they change. Yeah. So all of these are kind of version control. So you already kind of have in your head that you should be able to go back to the previous version of something. That you should be able to kind of see what you did in the past and understand why. And if you make a change, you should be able to go back and you should be able to kind of understand where things came from and then be able to access the past version. So this is a folder on my computer. So this is like my supervisor edits it and then me again, and then me, and then him. So this is a pretty common version control system, and I just want to stress that this is not like wrong or anything. Like this is functional in the sense that you can go back to previous versions, but Git and kind of more formal version control systems like Git will help you do this in a nice, elegant way that is very controlled by you and that doesn't take up tons of space. You don't end up with like 100 copies of a file. So the kind of philosophy of Git is that instead of saving nothing, so instead of just never saving versions of things, or just always overwriting your past stuff, or instead of saving everything, which is like doing the _v1, _v2, et cetera, you only save differences. So you save only the changes that you make. And so we're going to kind of see how this works, but the idea is that you can save kind of time and space and logic in your brain and save only the differences between different versions of things. So just a quick note about Git and GitHub, because some of you mentioned that you have a GitHub account, or you've used Git, or you've installed it, but you don't know kind of the relationships. So Git is the command line software that actually does version control, and GitHub is a service that hosts code and things like that, and it's running Git in the background. So you can do most of what we're going to do on Git also in GitHub, and kind of vice versa. So you can think of them as being related. GitHub is becoming very popular for collaboration and for open source everything. So I first kind of got introduced to Git by being forced to use GitHub. So I think that's kind of a common path into Git, is like you see GitHub, you have to work with somebody who's using GitHub, and then eventually you need to learn Git. So that's why we're doing this right now. So like I said, I encountered Git this way through GitHub. And I didn't use Git for a long time. I resisted like actively for a year or so. It seemed really hard, like it was just very confusing. My entire experience with it was somebody sitting over my shoulder being like, okay, type this. And I would type exactly what they said. And they'd be like, okay, type this. And I just had no idea what I was doing. And also I had a system that was kind of saving versions of things that I thought was working okay. And that was dated folders. So every time I worked on something, I would make a new dated folder and then copy everything that I had been working on into that folder. So this is fine, as long as you keep good notes, so you actually know where things are, or you don't do this for a very long time. So after about a year of this, you have like 200 folders, and I'd be like, oh, I remember that I made this cool plot in like roughly August, but then I'd have to open like 20 folders in August to find it. So I started using Git after I, was spending a lot of time looking for stuff that I'd done in the past, and I had no kind of notes of when things had happened. And I was forced to use GitHub for a project. And then I had a few cases where I was working on some code and then something just inexplicably stopped working. And I had started using Git, and I was able to go back and see what had actually happened. So Git, I'm a believer now, I have to say. I was not originally, but now I am. If you're not convinced just from that, Git is now the most popular version control software. So this is from 2014, so it's, I presume, kept going up since then. These other ones, like CVS and Subversion and Mercurial, are other similar things to Git. They're just different ways of doing it. So if you're going to learn version control, Git is definitely the way to go. Okay, so now we're going to see how Git, I should say Git, not GitHub, how we do this in Git, how we save changes. So yellow stickies again, if you have a terminal window open and you can type git -- version and you see something like this. Do you guys want a minute to set up at all? Okay. So you put up the yellow sticky if everything's good, put up the pink sticky if everything is not good. And if you need help, like installing something, put up the pink sticky and somebody will come help you. Okay, so the first thing we're going to do, how many of you have not used Git before on your machine? Okay, perfect. So we're just going to set some kind of global configuration things, which is your name and your email, so that Git knows when you make a change, who to attribute it to. And we'll see a bit later how we can use this. So I'm going to type commands, and you can type them along and then run them with me. So first one is git config. So everything in Git starts with git and then space and then the name of the command in Git. Git config, space, -- global. And now user.name, space, and then in quotes, write your name. So I'm going to write my name. Don't write my name. Otherwise, all of your changes will be attributed to me. Maybe you want that. I don't know. So git config space -- global space user.name and then your name. And then you can hit enter once you've done that. So if you type something wrong, you'll probably see some sort of error message. But if you typed everything right, there's no output. You just set this variable kind of in the global settings. So the next one we'll do is just set your email, git config -- global, same as before. And now it's user.email. And you can put your email address here. So, sorry. I'll send one of those guys over. If you have an account on GitHub, this does not have to be the same email address as that. This is just like a contact email. Like if your commits are showing up somewhere, this is the associated email. So put up your green sticky again if these things worked. Okay. So to see what we've got in our config, we can type git config -- list. So instead of -- global, -- list. And this will list, kind of as suggested, it'll list all of the configurations that you set. So if you're on Windows, you probably have a huge list because there's a bunch of things that get set by default. So it should say somewhere in there, user.email, your email, and then your name. And this is sort of optional, if you want to use a different editor than what it says on there. So I'm using my default editor is Nano, which is a text editor. So if you have, say, Notepad++, you can set, the same way we set these ones, you can set the core editor to be something else. So if you want to do that kind of for yourself, we can help you with that afterwards as well. But it's not necessary for now. Okay, so now, how many of you have used Bash before? Like, occasionally? Okay. So we're gonna be using some Bash commands to navigate. This is not super necessary to understand, but I'll kind of say what they mean. Okay, start at the top. So let's go to our desktop. So to navigate folders in Bash, the command is cd, which stands for change directory. And I'm typing ~/desktop. So the tilde stands for home. So this will take you to your home directory, whatever that is for your operating system, and then desktop. Yeah.
Sorry, what do you mean by Bash and terminal the same thing?
Yeah, sorry. Bash is a particular, they're synonyms for me. They're not technically synonyms, but Bash is like a form of language that you can use in terminal. Yeah, so if you have terminal on Mac, you're using Bash. So nothing will show up again because we just kind of moved directories. So now after running that, you can type pwd, which stands for print working directory, and hit enter, and you should see that you're in your desktop folder. So just for consistency, so that we're all in the same folder, we'll do this on desktop. You can, of course, do this wherever you like if you don't like working on your desktop. So what we're going to do kind of to practice Git is we're going to make a folder and then go into that folder, set it as a Git repository, and start making changes to files in that folder. And then we'll see how Git kind of tracks things. So you can initialize Git, which is what we're going to do in a second, in any folder on your computer that already has stuff in it or that's empty. Let's say you've already started writing a paper and you want to start putting that under version control. You can go into that folder and initialize a Git repository, and then everything in that folder you can now use Git with. So I'll say that again when it makes more sense, once you've done something. So let's make a directory now. mkdir is the command, make directory, space, and then the name of the directory. So we don't need quotes because it's expecting a name of something. Again, there's probably no output here. Actually, hold on, don't type this. Okay, I'm gonna do it again. No output here because all you do is make a directory. If you run the command ls and hit enter, you'll see everything. This lists, ls stands for lists. This lists all the files that are on your desktop. So I have some like other stuff here, and then down here is the thesis folder that we just made. So we can go into that folder again with cd. Let's move this up. So I just did ls. I did mkdir thesis and ls. The hash symbol is a comment, so it's not actually going to be run. And now we're going to cd thesis. And one more pwd shows us that I run this folder. So put up your yellow sticky if you are inside a folder called thesis somewhere on your desktop, hopefully. Okay, so now we have a folder. Let's pretend that this is my actual thesis folder and I want to put it under version control. So to initialize a Git repository, so a repository is what a collection of files that's under version control is called. The command is git space init and hit enter. And after you type git init and hit enter, you'll see some message, initialize empty Git repository in that folder. So if we type ls, nothing shows up. So there's no files in here because I didn't actually do anything yet. It's just an empty folder. But if you do ls-a and hit enter, now you'll see dot, and .git. So dot and dot are shorthand for this folder and its parent folder. But .git is a new folder that was created when we ran git init. So this is what actually stores all of the changes that you make when you run git commands. So don't delete this. If you see it and you're like, why is this have this weird folder? If you delete it, you delete your history. So keep that folder. And again, you can run this command git init in any folder that you like. It can have stuff in it already. That's fine. But it's not a good idea to run git init inside another Git repository. So if I were to make like an introduction folder and then run git init inside there, then it would be kind of confused about where kind of to store things. And the kind of general idea of where to use git init is anything that you would think of as a project should be under like the same version control. So there should be like a top level folder for that project. You would run git init in that folder, and then everything that's in any subfolder is all part of the same repository. Does anyone have questions about that so far?
There's no space.
Okay.
Just git config.
So now we have initialized Git repository, so now we can start using Git commands to make changes and save changes. So the first and most handy command these again, show you what we did. We did cd thesis, and we did git init. The most handy command that I run every other time I do, every other command is this command, git status. And then hit enter. So whenever you run git status, it'll tell you the status of your folder. So we see a couple things on branch master. We're not going to talk about branches, but the default branch name in Git is master. So this is like the timeline of your directory is like a linear chain of events basically, and its name is master. You can have branches coming out of there, which I think we're going to talk about next week, but we're not going to talk about it today. Initial commit, I think that means that we made a Git repository, and then nothing to commit. So there's nothing that we've actually changed that we can add to Git right now. Well, let's make some changes. Okay, so I'm going to make a file. It's going to be an empty file using the command touch intro.txt. So this is my thesis. I'm going to write an intro. That's going to be a text file. Once I type this, then I hit enter. Now when I hit ls, run ls, enter, now I can see that there's one file in here called intro.txt. And another bash command that's really handy is cat, intro.txt. So if you do cat and then file name, cat stands for concatenate, so you can kind of you can concatenate files, but you can also just run it on a single file, and then it will just print the contents of that file to the screen. So when I run this, nothing happens because there's nothing in this file. Touch, you could think of it as like changing the timestamp of something. So when you do touch file name, it's like you've opened it and closed it. If that kind of makes sense. So that's what touch does. It's not super important. Okay, but let's do git status again. I told you I run git status all the time. Okay, now it looks different. So I ran git status on branch master, untracked files. So now Git knows that there's a new thing that it hasn't tracked because we made a change. Nothing added to commit, but untracked files present. Use git add to track. So there are sometimes helpful suggestions of what commands would make sense to run. Here it says use git add, which is the correct thing to do. So the cycle, I'm going to do it once, and then we can talk about what it means, the cycle of adding a change and saving it in Git. So the first thing to do is git, let's do this, I did git status, git add, and the name of the file, here intro.txt. One other thing, when you're typing in bash, you can hit tab, and it'll autocomplete whatever you're typing. This is really handy for spelling mistakes. So for example, I had started typing into, and if I hit tab, nothing happens now because it's like misspelled. So it helps you kind of avoid spelling mistakes and kind of type faster. Git add intro.txt. Okay, let's do status again. Git status. We're literally running git status every other command. Now we have new things to look at. On branch master, changes to be committed. And now this file was in red before, now it's in green. New file intro.txt. So git add has taken this file and added it to some mystical staging area where now Git says we can save this change. So the types of changes you can save are changes to the contents of the file, changes to whether a file exists or not, that kind of thing. So the last thing to commit it is git commit. Don't hit enter after you hit git commit. if you do, I can help you, but don't. Git commit, add, starting, intro. So you can type whatever message you want here. Commit is the name for like a change. It's not a very intuitive name. None of the names in Git are that intuitive to me. So you just kind of have to remember a commit is like a discrete change that you saved. So this command git commit is going to take the file that we've added and save that change. And then the -m here means add a message. So, and then in quotes here is the message. So this message is attached to the change. And the messages are super helpful. This is for you when you're going back later and being like, what did I do to this file on this day? You can see the message. The messages say what you changed and maybe why. The rule of thumb for these messages is that they should be kind of short, but not like super descriptive. So you wouldn't want to be like, added some text and then like the actual text that you added. But if I just said change, then me in 6 months is going to hate myself. So it's good to be like, I'm doing this thing, create file for intro draft, something that makes sense. And then hit enter. And now you'll see a message that says what you did and what the changes were. So here, create file for intro draft is the message. One file was changed, 0 insertion, 0 deletion. So we didn't actually add anything to the text. We just created it. Let's do git status again. Now it says on branch master, nothing to commit, working directory clean. This is a nice thing to see when you run git status. It means that you've saved all your changes, you've recorded everything, nothing is kind of hanging out. In practice, I always have a lot of files just that are untracked hanging around, but you can deal with that as well. Okay, if you typed git commit and enter by mistake, which happens all the time, here nothing will happen because you don't have anything to commit. But if you do that, it'll pop up the default kind of text editor, which usually is Vim. And Vim is like, I think it's like the most popular Stack Overflow answer is like how to exit Vim. So it's kind of famously hard to get out of. So if you find yourself stuck in Vim, you have to do escape and then : Q ! Enter. So there's like a series of people love Vim. But if you get stuck in Vim, just Google how to get out of it. Or if all else fails, you can just close your terminal and reopen it. This is tried and true. Okay. So let's do one more of those. Let's make a change and save it. This time, let's actually add some text. So here, I'm going to use a text editor called Nano. So type nano intro.txt. This will launch this file in a text editor. So if you try this and it doesn't work, you can also just like navigate to your file, like thesis, intro. You can just open it however you like to normally, and then write something and save it. So you don't have to use Nano. But if you have it, you can just follow along that way too. Okay, nano intro.txt. So now I'm looking at, this is a text editor. I'm looking at this file. It has nothing in it. I'm going to write some stuff. Draft intro for my PhD. I don't have a title. Bacteria, virus, interactions. That's enough. Okay, so once you've written some stuff, in Nano, it's Control X to exit. And then it'll ask you if you want to save changes, and I'm going to hit Y for yes. And then enter again for the file name. Okay, hold on. My Flux has told me that the sun is set. There we go. Okay. So put up your yellow sticky when you've made a change. Sorry, yes, question.
Are you using Nano text file as an example, but this works for like all file type, like regardless of the interface I'm working with and file type I'm working with?
Exactly. Yeah, that's a great question. So I'm using a text file just because it's kind of a simple way to see changes, but you can do this on any file type. There are some file types, you can edit it however you like you can edit things in Word or whatever text editor you like, or whatever IDE for coding you like. There are some file types that don't show up nice when you try to view the changes. So in a minute, we'll see how to view the differences between files.
You use it for like image processing and image control?
That's a good question. Images are tricky because when you look at a difference between an image, it'll just show you like the big long binary or like weird character thing.
Yeah.
I think there might be other tools that do image diffing better. But you can definitely be like, this is the new version of the image. It's just that you won't be able to easily see what the changes were.
You'll have it all saved in Git and then having like folders with multiple versions.
Yeah. The difference is though that in that case, it doesn't really save you anything on space because because Git doesn't know how to interpret what changed, it'll just save the whole thing again. So then your Git folder will get large. It'll be as large as if you saved each version of the image. So
And that goes for all text files.
no. So for text files, because it knows how to interpret changes, it'll only save the change. So it is a lot less space that way. Yeah, good question. Yeah, if you want to talk about specific file types, we can talk about that more later too. Okay, let's do git status. So now instead of new file or untracked files in red, now it has modified intro.txt. So whenever you add a file and then commit it, it becomes tracked. So that means that Git is watching it and it's going to look for changes. So every time you run git status, it'll look for changes in any file that's tracked. You can have files that are never tracked by Git and it will never tell you. It'll just say this is a new file, but it won't tell you when you change things until you save that first commit. You can also tell Git to ignore certain files or file types or things like that, which we can talk about later as well. But it's pretty hard to unignore a file, it's pretty hard to untrack a file. So if you start tracking it and then you're like, oh shoot, I actually don't want to save these changes. It's possible, but it's kind of tricky to delete the history. Okay, so now we have this file that we're tracking. Git says modified. Again, we have to do git add intro.txt. Enter. And let's do git status again. Now it's in green. Changes to be committed. Intro.txt. So the reason why there's this kind of two-step process, like why it's just not git commit when you make a change, is that it gives you total control over what each commit contains. So the most kind of practical example of this is if you are changing lots of things, like lots of different files, and then you want to kind of group a few together in a certain message that are related, you can add those particular files and then commit it, and then add some other files and commit it. It just gives you, it's like if you're trying to take a group picture, you want to like take certain groups at a time, you like click. You don't want to just like take the whole group standing around. You get to give it that way. So now we have this thing in our staging area. Let's commit it. Decided git add intro.txt. Now we're going to do git commit. Just for illustration, I'm going to hit enter without doing the -m. You don't have to do this. Okay, I think because my default is nano, it sent me into nano, which is convenient because I actually know how to get out of it. But again, if you're in Vim, put up your orange sticky. Get help. Okay, so let's just exit this. So Git will not let you have an empty commit message. This is kind of saving you from yourself. It forces you to always say something. So let's try again with a commit message. Commit -m, add title. Enter. So now it says we changed one file and we added 2 insertions. So here the number of insertions is the number of lines that were changed. Okay, so if you want to see a list of the things you've changed, the most important thing here, I mean, we've saved some changes, but how do you actually access those changes? How do you go back and see what things you were doing? So one handy command is git log, git space log. So this gives you a list in reverse chronological order of your commits in that directory. So we only have 2, so this thing is not too long. If you had lots, it would show you kind of like a paging view, and if you hit enter, it'll keep scrolling down. To get out of that, you just type Q. So let's see if I make this bigger. No, I can't make it bigger. Yeah, so if you want to get out of the paging view, just hit Q. Again, worst case scenario, just close your thing and open it again. Okay. Log. We'll see. We'll come back to git log. Okay. Let's make another change. nano intro.txt. Bacteria are the most abundant life form on the planet. Unless you like viruses better. So I'm making a change in this file. You can change it however you like. It doesn't have to be like a real change. And then I'm going to save it. Control X and nano, Y, and then enter. So now let's do git status again. Git status is like a reflex for me now. I do actually use it all the time when I'm working in a Git directory. So now, again, it says modified this file. You can use cat if you feel like it to see what's inside that file. Cat intro.txt will show me what's inside there. Now let's do a new command. It's called git diff. Git diff. So this is kind of where the power of Git comes in and why certain file types are better than others for Git. Here is a couple lines from the file before the change. And then in green here, this is everything that I changed. So what it's showing me when I just run git diff by itself is the difference between the last saved version of that file, the last commit, and whatever is in my working directory. So whatever change I just made. So here it shows me new line, header, new line, sentence. Those are the changes I made since there. And there are a ton of optional arguments for git diff to compare different things, different time points. I'll show you some of those, but there's kind of, you can compare any two versions of anything, anywhere in your history. And this is super useful. Yeah, question, Noah.
How did it know to show us the diff for intro.txt?
As opposed to?
If we had several files.
Yeah, if you had several files. So if I made a new file like touch.a.dat, and then ran git status, you want to do this. So now it shows me my modified file and an untracked file. If I do git diff here, it's still only going to show me intro because it's the only one that it's tracking. But if I were to add, so like git add a.dat, and then do git diff, oh, maybe still not. Okay, it has to be tracked. Any tracked file that you've changed, it's going to show you that in git diff. So it's not, it can be, git diff by itself is not super useful if you have been changing lots of files because it'll just show you them all one after the other. In this case, there's only one, but you can specify, for example, git diff intro.txt, and this will only show you the diff for one file. So this is more useful, I think, because then you can just say, I want to see what I changed on this file, only the differences between it and the last saved version. So this is nice if you're about to commit something and you're like, okay, now's a good time to commit, but like, what did I actually do? You can run git diff and it'll show you what the change is that you're about to add. Okay, another one that I use a lot, that's sort of like doing git diff file name. So let's add that file, git add intro.txt. I did git add intro.txt. So now if I run git status, okay, so now I have a situation where I want to have control over my staging area. So I actually decided I don't want to add this file that I just made. So I can remove it from my staging area with this command, git reset head file. So sometimes these suggestions are helpful, as in this case. So I'm going to do git reset. If you didn't add that file, that's okay. Git add. And then if I do git status again, if I did git reset a.dat, now it's been taken out of this green area and back to red. Now it's back to untracked. Head is the kind of code name for the top of your history. So it's they'll call it also the tip. So it's like the most kind of current place. It's the last change you made. So when I say git reset head, it's like take the staging area thing back to where it just was. Okay, so now I can do, if I did git diff here, it won't show me anything because I've added intro, which is the only thing that actually changed. But there's a special flag for git diff. This is super low down. Git diff -- staged. I love this one. I use it all the time. So I know I'm going to commit some file. I add it. Now I want to refresh my memory. What did I actually change? I run git diff -- stage, and it shows me the same thing as if I had done git diff file name before I added it. Okay, so let's do that commit then. Git commit -m begin intro text. These commits are sort of a little too frequent, so it's hard to make the commit messages meaningful. But in general, I do like whenever I think that I've like done something, I try to commit it. Commit early and often, as they say. Okay. Let's try committing that file that I just made. So if you didn't make a file, make a new one. Run touch b.dat. Pretend this is a data file. The extension doesn't mean much. So if I do ls, I now have these files. You might only have, did anyone do a.dat as well? Okay, I'm just going to remove it then, so we're all on the same page. Okay, so now we have this new file, intro.txt. Let's run git status. It shows us that we have this untracked file. Let's do git commit -m add a new file. Okay, so actually nothing happened because we didn't actually add it first. So if you run git commit before you run git add, nothing will happen. It won't commit anything. So it's always git add, git commit. It might seem like unnecessary steps, but again, it gives you this total control. Okay, so the really powerful thing, again, is being able to access things that you did in the past and see them and compare them with other versions of things. And I think this is the part that took me a while to kind of see in action. So I'll try to hopefully say it in a way that makes sense. Okay, let's make another change in our intro file. I'm going to edit it. They can make a new line. You can metabolize almost anything. I made a change to my file. Again, if you run git diff here, it'll show you the change that I made on intro. But you can be a little more specific. Git diff, if I do head intro.txt, this will actually give me the same thing as if I just did git diff intro.txt. Git diff head explicitly says compare the new changes with the last commit. So I see the line that I added. So actually, here I took off a space at the end, so that's why this line looks different. And then I added this new line. You can also, and this is where it gets really cool, go back in time further. So if I do head ~1 intro.txt, I get the previous commit. Now this is the difference between my current file and two changes in the past. So it has the new line that I added and the one that I added before that. And you can keep going as far as you want. Git diff head ~2 intro.txt. And now I have all the changes because I've only made 2 commits. If you can try this yourself. If you try a number that is like too far back, I think you might get an error, but you can try it. Okay, so remember we did git log, and git log showed this long list of all the commits that we made. So here now I'm in this page mode. This colon here means that I can kind of hit enter and scroll through things. And then I hit Q to get out of there. I did git log. So this string of letters and numbers here, that's the commit and thing. That's the commit ID, and that's unique supposedly in the universe. It's long enough that it would never appear again in the lifetime of the universe, is the idea. So that's a little, bit of overkill, but anyway, it means that your commits are unique in time and space. And if you are kind of sharing work with other people, your commit ID is uniquely tied to that exact thing that you did at that exact time. So you can use this ID to access specific changes. So let's do, okay. I'm I'm going to copy one here. So a handy thing is that you usually only need to remember the first like 4 or 5 characters when you're referring to these, because again, it's like 30 long, but really practically 5 is enough to identify it for you. So I'm going to copy these because I'm going to clear this, but you can just leave it up and look at yours. Now we can do something like git diff and then paste or type out the start of one of those IDs. And it's like doing head tilde the number that commit was back in time. So in this case, I took the last commit, or sorry, the most recent commit ID. So it's showing me the most recent changes. But if you picked one from further down, it would show you kind of more changes depending on which one you picked. You can also, and this is one that I use all the time, if I'm trying to figure out when I did something that broke something, you can use 2 of these and do like, okay, I'll show you. So I need git log again. A8F1. Okay. A8F1. Git diff this A8F1. You can type 2 of these, 2 commit IDs, and it'll show you the difference between those 2 commits. Here, because of the order I typed them in, it's showing me that I deleted this, so I should have actually switched these in order to show that it was added. This is one that I find super useful. You can also kind of chain, so one actually handy bash tip before I keep going. If you hit the up arrow, it'll show you what you typed most recently. You can keep hitting up to get your previous commands. This is handy if you're doing like git add same long file name over and over. You can just up arrow, hit it again. You can add here the name of the file to show you just the differences in that particular file between these 2 points. So again, this is nice if you're changing multiple files, kind of going back and forth. If you were to do git diff 2 commit IDs, it'll show you all the changes when you might just want to look at one file. So this will show me again just the intro.txt. It's the only file we're working with, but it's still helpful. Okay. Are people hoping to leave at 7? Put up your hand if you're going to leave at 7. Okay. We'll take a pause at 7 then. The last one that really kind of changed my life when I was learning Git is checkout. So you can see differences between things, but what if you actually want to go back and use something you were doing before? So this is something that I think we kind of intuitively know when we're doing like save multiple versions, is that you would want to actually go back and potentially go off what you had before, or like copy it and paste it into your new version. So the command to do that is called git checkout. Okay, so let's pretend that, okay, so in this case, we have some changes. Let's do git status. I'm going to just add these and commit them. Git add intro.txt, git commit intro. If you're going to run git checkout, it's going to take you back in time, and it'll delete. If you're doing this in a particular file, it'll kind of remove the changes that you haven't committed yet. So I like to just make sure that I've committed it, even if I'm not going to keep it, just so that if I do want it back, I can get it. So git checkout can kind of function the same way that git diff works, where you can give it head and then a number to go back in time. So before I run that, let's just look at what's inside this file right now, cat intro.txt. So let's say that I want to delete the last line that I wrote. So one way to do that is go in there and delete it, but I could also just pull out the change. I can pull out the file as it was in the past with git checkout. Git checkout head tilde 1. So I'm going 1 commit back from my current commit and the name of the file. So run that. Now if you do git status, it right away puts it into the staging area, thinking that you might want to commit it again. You could actually kind of just keep hopscotching back and forth with changes. But this is the thing that it took me a while to realize. Now that we've run this, this file is actually changed in our directory, in our working directory. So if you go and look at it, if you use cat perhaps, or if you just open it however you like, it's actually like physically currently changed to the previous version. So if I were to go here and open it, it's back to where it was before. So you could, at this point, edit it, do something different with it, copy it and paste it back in the current version, but git checkout and then either a commit ID and the file name or a head number file name will pull into your current working directory the thing as it was at that point in the past. Okay, let's wrap up for now. Okay, so just a few things in closing. We've been working kind of all in this terminal, mostly just so I wasn't switching windows all over the place, but you can, as I said before, make changes to files any way that you like. So if you're coding and you're using some interpreter, you can do all that exactly as you would. Come to your terminal, do git status, see the changes, do git add and git commit, and then only do those git commands in there and do everything else as you would normally. You can track any type of file. You can track changes to any type of file. Certain files, like text files, work really well. I've actually never tried to track like a Word file, but that's kind of one reason for using plain text, if possible, or things like Markdown, is that it's kind of easier to use in a thing like Git. There are some fancy kind of flags you can add to these commands to make things look nicer. So for example, git diff, let's do head, and then @ color -words. So this is going to show me the diff between current and 2 commits back, but adding -- color words will show me, in this case it doesn't really apply, but it would show you only the specific words that were changed. So for example, I worked on a document in LaTeX, and then I was writing these big long paragraphs, and each of those is kind of one line in Git. So when you do git diff, it just shows you the entire paragraph. But if you use something like color words, or there's another flag, word diff, it'll show you only changes to the words that you changed and leave the rest that wasn't changed in the paragraph alone. So this can be helpful for kind of seeing what you actually changed. Okay, so let's stop there. And if you want to stick around and talk about GitHub, feel free, but we'll take a little pause now if anyone has questions. So thank you all. Yeah, question.
When you're tracking LaTeX files, do you include the PDF and all the other like LaTeX output?
No, I only track the text file.
Okay.
So the question was, if you're working with LaTeX, how many of you work with LaTeX? Okay, so this won't apply to you if you don't, but LaTeX is like a plain text way of writing documents with like weird commands, and then it generates PDFs. And it generates a lot of other kind of extra files as well, like logs and auxiliary files. And generally, you don't want to track those in Git because A, they don't really mean anything, like you didn't change them, so you don't understand why they would change. And also, the text file is enough to recreate everything else. So you only want to track in Git the file that you the master file. So I would never track PDFs. For the same reason that I try to avoid saving images in Git, because the diff doesn't really look nice. Yeah. You can set Git to ignore certain file types. There's a special file called gitignore. Gitignore. Yeah. And here you can do like star.pdf, which means ignore all PDF files. If I had a file that was a PDF file, Git would just completely ignore it. It wouldn't tell me it was there. So for LaTeX, I add to the gitignore all of the LaTeX special files. I add images, I add, yeah, that kind of thing. Like when I'm running code that generates figures, I've started now doing this kind of hybrid where I save the figures in a dated folder, like a results folder, but I only do version control with Git on the code part. Any questions before we do GitHub quickly? Yeah.
Kind of related, but is there any way I can save like all the commands outside thing?
Excellent. Excellent question. So like the commands you were just doing in Bash. So the command history, if you type history and then hit enter, will show you kind of in reverse chronological order all the commands that you ran. So if you want to save this to a file or something. Here, I'll make it on the top. You can do history and then kind of a sideways arrow thing. A file name, history.txt. And now I have this file, history.txt, which has all those commands in it. Yeah, good question. Okay, so let's talk for a little bit about GitHub. So GitHub is like a web hoster for Git. So it runs Git in the backend to do version control. It knows things that you've done on your computer. You can set it up to kind of talk back and forth with your computer, which is what we'll do now, just to show you how that would work. So if you're on GitHub, go to your profile and click your profile. And then go repositories. And somewhere there should be a button to make a new repository. Ah, here it is. So click the green new button on the repositories, and then put up your yellow sticky when you have done that, when you're here. So what we're going to do now is make a repository on GitHub that's going to match the repository that we just made on our computer. So I'm going to call it thesis. Shoot, I already made thesis on this account. Thesis 2. It only has to be unique to your account, so it doesn't have to be like unique in the universe or anything like that. Leave all the rest of this off, and in particular, leave this unchecked. So don't check initialize this repository with a README. And then when you've done that, click create repository. So this is now like an empty area on GitHub, and we want to connect our local repository on our computer to the GitHub version, so we can kind of pull and push changes that we make with we can sync it with the online version. Just a note about GitHub. This is by default public. So there was an option when we did new repository to make it private. I think you can do that if you have an educational account, which students can get. But in general, these are public. If you don't want to use public repositories and you don't want to get an educational account and you want to pay GitHub, there's something called GitLab, which has free private repositories, and it's kind of exactly the same as GitHub, just a different company. Okay, so now we have to, on our local version, tell Git that there is another version out there that it wants to sync with. So copy this URL. If you don't use Git, you almost certainly want to use HTTPS, which should be the default. So copy it, and then back in your terminal, we're going to type git remote add and then origin, and then paste here the link that you copied. So if you're on Windows, I think you might have to do like click on the little icon on the top left of your terminal, and then there's like an edit button, and then if you go to the right, there's a paste option, because I think Control-V might not work. Okay, so this command, git remote add origin. So origin is a nickname that this URL is going to have. So now whenever we refer to origin on our local version, it knows that it's referring to this URL. This could be anything you want. It could be like fun place or your name or something. But like origin is kind of the standard name for the thing that's directly synced to your local version. Okay, so let's run this. Nothing shows, but if we type git remote -v, -v stands for verbose, so it shows us what the remotes are. Remote is like what other repositories are known about by this one. So it should show you that link that you just copied, and one thing that says fetch, and one thing that says push. So this means that you have rights to change the upstream, or sorry, change the online version, as well as get changes from it. That's fetch and push. So now we've got nothing on the online one, but all our stuff is local. So to send our local stuff to the online one, the command for that is git push. So you can, in theory, just run git push by itself, but you generally should specify which remote repository you're specifying. So here, git push origin, and then also the branch name. We didn't talk about branches. Right now there's only one, but it's called master. So we're going to do git push origin master. This is one of those kind of standard things that I run all the time. Git push origin master is a very kind of common command. So this might prompt you for your GitHub password. If it doesn't, it should just kind of say all the stuff. This is like a nice scrolly success message. It tells you that it's writing some stuff. So to GitHub, this repository, master, going to master. Okay, so put up your yellow sticky if that worked. Thank you if it didn't. We got a few that didn't work. Okay, so if you didn't get like some error, to confirm that it worked, let's go to GitHub and just refresh this page.
Oh, I did just use the water.
So once you've done that, if you go back to your repository on GitHub and refresh it, you should now see the file or any files that you added that we added now. So here's just intro.txt. So I can click on it, it shows me what's in it. GitHub has a very slick looking interface, I think. It also can show you all the commits. So here it shows us the 4 commits. If I click this, it shows me again, reverse chronological order, what all the changes are. You can click these buttons, do something. This button is handy. If you click it, it'll take you back to that point in history. So you can kind of, it's sort of a git checkout. You just go back to that commit. So if I go here, now I'm back to where intro.txt only had the first couple of lines. But now since I've gone back in time, this thing says tree blah, blah, blah commit ID instead of master. So to get out of here, just go tree thing master. Now we're back at the top. GitHub has a lot of other nice features for collaboration. So this issues tab. So UofT coders, if you go to our website and then you click like contact us or something like that, it'll take you to our Git repository. And you'll see if you click on the issues tab that we use this tab to kind of like as a discussion board. So we just put like volunteer opportunities or events that are coming up. We make a new issue and then it kind of gets sent to everyone who's following that repository. You can also send and receive changes from other people. So any of you now could go to my repository, make a copy for yourself, make some changes, and then send them to me as what's called a pull request. Again, kind of a weird name. And then I could decide if I want to accept those changes. So that's kind of how the cycle of collaboration works on GitHub. I think we might talk about that more next week, like working with other people on GitHub. I think using Git for yourself is one thing, and then collaborating is another thing that has other tricky things associated with it. But it's a great way to be forced to learn, which is what I did. And if you're not sold on using Git for yourself, just think of yourself as your #1 collaborator who would really like to know what you were doing 6 months ago. So future you is like your collaborator who's angrily emailing you, except for the problem is past you does not answer emails. So past you will not tell you why you did something unless you explicitly do. Okay, I'll stop there and we can talk more.